I am Krishna Rao Patro. Today, I'll discuss about one important problem, that is insertion sort. So, in the previous session, you have seen the general concept behind different types of sorting. Now, today we'll see how insertion sort works and what is that insertion sort. So, I can say insertion sort is one of the simplest sorting technique. The name indicates sort while inserting itself. That means while inserting the single element, you have to find the suitable position where exactly the data should be. That's why it is called insertion sort. So, this insertion sort is the simple one, which is consuming the same memory area, and it is not consuming extra memory, but it is in a linear in nature. So, the time complexity will be order of n square in the worst case. But in the best case, if the incoming data itself is in order, then it will be order of n. So now let us see what is that insertion sort and how it works. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. So whenever you are having a set of cards when you are playing, you may try to arrange them in order. So the time you are finding where exactly this card should be there. You are finding a suitable position of the card. So there you are applying your insertion sort. This array is virtually split into sorted and unsorted part. Sorted and unsorted. Because while giving the data, some part may be sorted and some part may be unsorted. So this unsorted data, it will find the suitable position. It will take time for moving the data from one position to another position until you find the suitable position for the incoming data. Values from the unsorted part picked and placed in the correct position of the sorted part. So you have to find the suitable place for the given data. And there is a simple sorting algorithm for the insertion sort. How it works, you see now. To sort an array of size n in ascending order. Of course, when I say sorting, it can be ascending order or descending order. Generally, by default, when you say sorting, always it is ascending order. Please remember. Generally, when you say sort, it is always ascending order. That is the default. Now, the algorithm says iterate from array 1 to array n over the array. So that means you have to start from beginning to till end. Compare the current element of the key to its predecessor. So in the insertion sort, wherever you are inserting, you have to compare with its predecessor elements. If this element is greater than the previous one, stop it. If this element is smaller than its previous element, then you have to swap it. You have to find the corresponding position until find the suitable position. So you can go until beginning or starting of the array. So this process will continue until the end. Wherever it finds the suitable position, stop it. If the key element is smaller than the predecessor, then compare to the elements before. Move the greater elements to one position up and make the space swap element. So if at all it is a incoming, means wherever they are putting, if this place is not suitable, then swap it. After swapping, again check its previous, whether it is smaller or greater. If it is greater, stop it. If it is not greater, then swap. So this process will continue until the starting position of the array. So wherever it finds its position, it will break. So this process will continue. Now if you observe here, there are a set of data. How many? 4, 3, 2, 10, 10, 12, 1, 5, 6. There are set of data. Now please observe here, 4 is as it is. Because first element, no need to do any swapping. Second element onwards, it will compare its previous. Now 3 is smaller than 4, so you have to interchange. So 3 and 4 interchange. Now next data is 2. Now 2 is greater than, means smaller than 4. So 2 and 4 interchange. So 4 will come here, 2 will come here. Again compare 2 with 3. So 2 is smaller than 3, so interchange. So finally I got this 2, 3, 4. So until you find the correct place, it will be repeating that many times. The loop is repeating. Next element is 10. So initially you have given the array. Now every position of the array you are checking. Okay. Now fourth element is 10. When the fourth element is 10, 10 is greater than 4. So no need to do swapping, because this itself is current. Up to this it is fine. So 10 is greater than 4. So it will stop here itself. After 10, the next element is 12. So now 12 is greater than 10. So stop it. No need to do any swapping. So every time whenever the new data comes, you have to compare with its predecessor, its previous element. If this element is greater than its predecessor, then stop it. No need to do any swapping. Next element is 1. When 1 comes, compare 1 with its previous element. Previous element is 12. Now 12 is greater. So 1, 12 will be interchanged. So 1 will become here. Again compare 1 with 10. So 1 will come here, 10 will come here. Again compare 1 with 4. 1 is smaller, so interchange. So 4 will come here, 1 will come here. Again compare 1 with 3. So 1 is smaller. So 3 will come swap. So 1 is coming here. Again compare 1 with 2. So 1 is smaller. So swap these two. So 1 is coming to front here. So this is the way continuing. Now the next element is 5. When the 5 comes, 5 you have to compare with its predecessor element. Now 12 is the predecessor element. So when the 5 is smaller than 12, then interchange. Then 5 is interchanging. Compare. So after interchanging 5, compare with 10. So 10 and 5 interchange. So 5 has come here and 10 has come down here. So that means until it finds the suitable position, it will continue. Now 5 is greater than 4. So stop it. So no need to do any more interchanging. So in the insertion sort, always you have to find the suitable position for the incoming data. Next is 6. 6 you will compare with 12. So 6 is smaller, interchange. Again 6 with 10, interchange. Again 6 with 5, no need to interchange because 6 is greater than 5. So that means 6 found here. This is a suitable position. So that means at the end of the loop, you will be finding all the elements in a sorted order. So this is the way it works. How to write the simple algorithm? You see, this is the simple algorithm. Now you are writing a program using Python. So write the def keyword and write the name of the function def sort and pass the array. Array means here the list. The list contain all the elements. Now this array having the set of data from 0th element onwards you have to go, but 0th element is no need to compare. That's why I'm starting from 1 to length of array. 1 to length of array. So I will continue till end. This key is now here. This element 1, 2, 3, 4. Initially my key is here. I will compare this element. I will compare with this previous element. That's why I kept the ith element in the key. After storing key, I will compare the key with the previous element. If this key, if it is less, then I will do interchanging. Ith element and so that means the j plus 1th element, j plus 1 place will be filled with j. And finally, when it finds the suitable position, the key will be copied. Key will be copied and my j will be keep on decreasing because I am going from last to beginning. That means my index assume at jth place, next time j minus 1th place, next time j minus 2 place. So every time j has to decrease till it find the position. So when the loop is terminating, the array of, because already it has decreased, so array of j plus 1 is my key. So key is copied. So this process will continue till end. So entire array is, once this is sorted, then I will print the entire array. So this is the simple AL program to print it. And remember the sorting time complexity. In the best case, the time complexity is order of n. Most of the time in exam they will ask what is the best case or best time complexity for insertion sort. This is order of n. And this situation arises only when if the data is already sorted. For sorted data, the time complexity is order of n because the incoming data is always only insert only. No need to do swapping because this data is always greater than previous. This will continue till n time. If there are n number of data, it will repeat n time. But in the worst case, if the data is in haphazard order, then every time it requires swapping. First data may be 1 time, second data may be 2 time, third data may be 3 time, fourth data may be 4 time, fifth data may be 5 time. So that means what? 1 plus 2 plus 3 plus up to n. That is nothing but n into n plus 1 by 2. That is nothing but n square time. So it is order of n square. So the time complexity for the insertion sort in the worst case is order of n square. Similarly, in average case also, the time complexity will be order of n square. So in worst case as well as in the average case, the time complexity is this. Fine. So this is the way you can define the time complexity. Okay. Thank you. Now we'll go for this ideal environment, how you can run. Now go to ideal environment. There you have to, this ideal is the special environment for Python programming. Now I will write my comment. Insertion sort. Here first my goal is what? Read the data. Array. Here I can put a message, enter the data. I'll print a message, print, enter data. Or you can, even if you can take the fixed amount also, means static data also. Now my array having the list of data. Here what I will do, int of I, input is my function, input dot split, input dot split, and for I in, because input dot split gives me a list. From this list I have to take one by one, and that I am converting into integer. Why? Because whatever the data you are reading through input, everything comes in terms of string. The string data I am converting into integer form. Now let me print directly, print array. I am simply reading and printing. Control S, insertion sort, F5. Assume I am entering 11, 44, 22, 33, 55, 61 and 52. Yeah. So it is giving the data. Now this data I have to go for sorting. Now this data is not in a sorted order, this is in normal order. So this data I have to pass as a parameter through my function. Let me go to my function. So this is my, so here I will write def insertion sort. Insertion sort. This insertion sort is my own function. So there I will pass my array as a parameter. So I got my array. So whatever the data is there, I have to sort it. So how many times I have to insert? Totally, if there are n number of elements, first element I have to skip. So that means 0th element I will not do any checking. From 1th onwards I have to go. So I will put a loop for I in range from 1 onwards, 1 comma length of array. So I got the array. Now in this for loop, every time I will take the last element, the ith element as my main key where I have to insert. So here I will take the key equal to array of I. So I got this. Now this element's position I have to find. Where exactly it is the suitable one. So I is available at the j place. So initially I will say j equal to, because the previous element's position is j. So j equal to I minus 1. So now whenever I is at the place where I have to insert and its previous element is j is nothing but I minus 1, previous element. So j equal to I minus 1 I got. So here I will put a condition while, because I do not know where exactly I have to insert. So I have to proceed until I reach the beginning. So while j is greater than or equal to 0. Because until 0 I have to track 0, and as well as the key must be less. If key is greater, stop it. No need to swapping. So if key is less than array of j, j is the index of my previous element. So I got this value. If this condition satisfies, then I have to do in j plus 1th place the previous element. That means array length of array ARR table. Yeah. Array. You must be very careful what the name you given. So array of j plus 1th item equal to array of j. So that means you are swapping. You are just shifting here. J plus 1th data you are shifting to jth place. And the j has to go back every time because you are going from j to till 0. So you reduce. So j equal to j minus 1. J equal to j minus 1. Once it find the proper position, array of j plus 1th place, because my original key is there still waiting, that you have to copy. Plus 1 equal to my key. So my key is copied. Once the entire loop is over, you will find your data. So that means here I will print the after reading the data, I will call my insertion sort. Insertion sort within bracket array. So that means what? Here I called my insertion method. After that, I will print the array. Control S. So here I can print a message after sorting. Print after sorting. This message will come. Control S, F5. Assume I am entering 11, 1, 22, 2, 33, 3, 44, 4. Assume this is the given data. After sorting, what I got? 1, 2, 3, 4, 11, 22, 33 and 44. This is the sorted form of this data. So, one of the simplest sorting technique, that is insertion sort. The name indicates you are inserting the data in the proper place. So, you must be very careful for this. Of course, if at all you are interested, you can take the static data also. And you can take even float data also. Assume you want to take float data. If you want to sort some weight of set of students, assume there are a number of students in a class, different students having different weight, 75.5, 69.3, different kg. So that input how will you do? Now here this program is suitable for now pure integer data. Now for float data how will you do? So what condition, what type of changes you have to do? For that, if at all you want float, same program. Now instead of integer, I'll write here float. Nothing else. Simply whatever data, because the input function always gives the data in string format. The string you can convert into integer, you can convert it into float. That means while reading, you are reading floating string. That float data you are converting, and you are passing there and you are converting. So now let us check F5. Assume while giving the data, I will enter 11.2, 4.5, 6.7, 89.67, 23.31 and 41.54. Now this is a given data. Now this data is in a haphazard order. So now, yeah, I got in a. So that means what? While reading data, the data you have to typecast into float type. In the insertion sorting algorithm, you will not change anything because the data is normal form. So this way you are able to do this sorting. And remember, this is one of the simplest sorting technique. And time complexity also you can note down. Time complexity is order of n in best case. Now they may ask a question, when the best case comes. Best case means what? Best case means if the data is already in a sorted order. If the data is already sorted order. If data is already in sorted order. In sorted order, then the best case comes. Whereas if the data is in non-sorted, that means in a haphazard order. So that means the average case and worst case. Average and worst case. This is order of n square. So order of n square comes only in the worst case. That means if the data is not in a sorted form, in a haphazard form. Yes, F5. If you observe, assume for example, I may give 1, 2, 3, 4, 5, 6, 7. I have given the data in already in the sorted order. So my sorting comes there. Now if you observe here, see data comes 1.0, 2.0, 3.0. Even though I have given 1, 2, 3. Why it is coming 1, 0? Because I have typecasted to float type. So while giving data, even if you are giving integer, but internally it is converted into again float type. Because here you wrote float. This float method means typecasting, which is converting the integer to float. So that means you can give either integer, it will convert into float, or you can give even float also, that will convert into float. So both ways are true. Fine. This is one of the simplest sorting technique. And remember, this is dynamic way of reading. This is dynamic. Where sometimes they may ask static data. That means I do not want to read data from the keyboard. I want to make it fixed. In that case, what you will do? I'll put comment. If data to be given static form, so I'll put this comment. So now in this case, instead of reading dynamic, I'll write here static. Static means it is not interactive. The user will give in the initial itself. So before executing, you have to give the data. Assume, and the data you have to give in a list. 11, assume 33, 3, 44, 4, 55, 5. Assume this is the given data. And remember, you have to write in a list form, the square bracket. Control S, F5. Yeah, 3, 4, 5, 11, 33, 44. So in both the way, you will get the same output. But reading data dynamic form is better one. So you can put this also comment and do. Both are correct. Most of the time, even in the exam also, they will ask the user to enter the data during runtime, and so that they will check. This is the best one. Static is not preferable, but you must know in both ways. Enter data 12.2, 3.4, 55.6, 77.9 and 1.5 like this. Yeah. So after sorting, I'll get my list. If at all you are interested not in the list form, I want to display in a normal without list form. In that case, how will you do? If you do not want to display in the list form, in that case, you can put a star symbol. If you put a star symbol, now if you observe here, Control S, F5. Assume I am entering 11, 2, 33, 3, 44, 4, 55, 5. Assume this is a given data. Yeah. Now, did you observe? There is no square bracket. There is no square bracket. Earlier there was a square bracket in the output. Here now there is no square bracket. If you want to observe, you can observe in both. See here, I wrote here star with star and without star. First I will write star, second one I will write without star. Control S, F, 11, 1, 22, 2, 3, 33, 4, 44. Yeah. Now this is without star. So that they got a square bracket. Whereas here, if you observe second one, there is no square bracket. So that means it is displayed in normal form without list. So if you want to combine everything without list form, so of course there is no comma also. Now that means what? It is displaying all the individual item separated by space. That is the nature of the star. So you can write print array, which will display in list. This will display in list form. List form. Whereas here it will display all the elements separated by space. All elements separated by space. Space without list. Without list. So both are correct. So whichever way you prefer, depending upon the requirement. Okay. Thank you. So remaining part will continue in the next session.
Like, share and subscribe. Hit the bell icon for more updates.